So one of the operators that we saw that we can overload is a typecast operator. So let's see if we can overload the float typecast operator and turn a fraction into a float. So I'm going to use a class called fraction. I'm going to create a class called fraction. It is going to have two private instance variables, a numerator and a denominator. I've already created an overloaded constructor for user-defined values for my fractions, and I've also created a destructor as well. And then we're going to create a function inline. We'll just create it inline to overload the float typecast operator, and then we'll go down here into main where we are printing or overloading even more operators, and we will test it out. So we're just going to use the keyword operator, and then the operator that we are trying to overload is that typecast float, and then I'm going to tell it that it is a constant, or that we will use a constant. And then inside of here, all I needed to do is to return, we're going to turn float num divided by float the denominator. And we're going to have it return that. All right, so pretty straightforward and simple. We're going to use the keyword operator. I'm going to tell it the symbol that I want to overload, which just happens to be the typecast operator for float. This will be a constant value that it is going to receive. All I need to do is to turn the numerator into a float, divide that by a float denominator, and then we will come down here and we'll test it out. So I'm going to create a fraction down here in main. We will create a new fraction object. I'll use the overloaded, we'll call it fraction, we'll call it F1. I'll use the overloaded constructor to make it 2 for the numerator and 4, or we'll make it 3 for the denominator. All right, so, and then I'm going to create a float variable. And then I'm going to set my float variable equal to my fraction, which is F1. And then we will just see out my float variable. So if this works, I'm just going to create a single fraction. We'll call it F1. I'm going to create a float variable because I need something to read back my float into. And then this is an implicit typecasting because it's going to take this object and it's going to try to put it in a float variable. And the only way that it's going to be able to do that is to convert it to a float. So does anybody know what 2/3 is in decimal? Hopefully you said 0.66. So now it has converted, implicitly converted my fraction into a floating point. Let's do another one. Let's create a second one. F2, we're going to use that operator. So how about the numerator will be 7 and the denominator will be 18. Now this is a fraction that I cannot convert on the fly. So we will say the float variable is equal to F2, and then we'll see out our float variable again. Oh, we called this, supposed to be an F2. There we go, much better. So we're going to create another one, 7/18. Does anybody know what the floating point value of 7/18 is? I have to break up my calculator. That would be an excellent test case. 3.889. I don't want to believe it just because I see it. I would want to have a test case, break up my calculator, write it down, and make sure that it is indeed 3.889. So now we can overload a typecast operator. As I said in the last video, there are certain operators that we can, a lot of operators that we can overload, and there are certain operators that we cannot overload. So here's a list, an example of some of the operators that cannot be overloaded. such as the ternary or conditional operator. That's the one we had in a prior video. There are a variety of operators that can be loaded, and here is an example of some of the operators that can be overloaded. So we overloaded the binary plus, and we overloaded the relational less than, and we also overloaded the unary increment operator, and then we overloaded a function call for the float typecasting. So not all operators can be overloaded, but a lot of them can.